Alright, this is Mr. Gillum, and today we're going to work on graphing proportional relationships. And in fact, we're going to learn that they're actually just direct variation relationships. And if we can remember some of the things we already know, we know that it should trend towards 0, 0, and the rate of change should remain constant. So you're going to see what the graph looks like here today. There we go. Okay. Now, they're going to give you a table and a graph. And first things first, you need to decide, well, is this a proportional relationship? If it's not a proportional relationship, we know that it's not going to go through the origin. But if it is proportional, then it should trend towards 0, 0 and go right through the origin, which is known as the point 0, 0. So it says, determine if it's proportional. Now we've done this in the past. What we need to do is we need to see the ratio from y to x, the independent variable and the dependent variable. Now, x is the independent, and y is the dependent. So we're going to say 4 compared to 2, 2. 6 compared to 3, 2. I'm just comparing these numbers here. 8 compared to 4 is 2, 10 to 5, 12 to 6. Hopefully everybody can see that the relationship remains the same every single time. But what we have to worry about is, does it trend towards 0? So it appears right off the bat that yes, this is a proportional relationship. But let's look at the graph to decide, is this going to trend towards 0? So what I'm going to do is I'm going to go ahead and I'm going to plot these points. Now if you remember, the x number moves the graph left and right, and the y number moves it up and down. So I will go left and right 2, in this case in the positive direction, and up 4. I'll put my first point there. And then left and right 3, up 6, so over 3, up 6. Put my second point. 4, 8, over 4, up 8. 5, 10, over 5, up 10. And finally over 6, up 12. Right there. Now, if we have a proportional relationship, and this is the truth, what we know is it should trend towards 0, 0. So let's see about where this graph's going to cross through the y-axis at. And to me, if I had a perfect straight edge, I would know I could keep continuing this trend all the way through 0, 0. So yes, I'm going to say this is a proportional relationship. My constant of proportionality, after I've checked and checked and checked and checked, I'm going to have to say that my constant proportionality is 2. So I'm going to say k equals 2. And so finally, we know the direct variation or the proportional relationship is y equals kx. I figured out that it is a constant change of 2, and so my equation shall be y equals 2x. And so it looks like a line. And we're going to learn more and more about lines later, but for now what you need to know is, because every time it goes over 1, it goes up the same amount, over and up the same amount every single time, it makes a line. It's a constant rate of change, and in fact it trends towards 0, 0, so it is a proportional relationship. Let's determine if the relationship, okay, same exact type of problem. So let's take a look at this beast. Let's take a look and make sure it's proportional. I'm going to compare the, see, this is the independent and this is the dependent variable. 6 compared to 1, and then 8 compared to 2, 10 compared to 3, 12 compared to 4, and 14 compared to 5. Now let's look at what happens here. I have 6, I have 4, I have 3 and 1/3, I have 3, I have 2 and 4/5. Now it looks to me like it's not going the same rate every single time. So I'm going to say this is not proportional, but that doesn't mean I can't graph it. I have all these nice data points here that I can still graph. So I'm going to go ahead and do that. I'm going to go over 1 and up 6, over 2 and up 8, left and right 3, up 10, 4, 12, and 5, 14, way up there, way out the graph even. Okay, now it looks pretty straight, but the problem is, if I made a straight line through them, it doesn't look like it's gonna actually go through 0, 0. It's not going to go through 0, 0. So this is not proportional. There is no constant of proportionality, and there is no equation for this guy that we know how to find yet. All right. So I think if you drew a really straight line, I think it would be even farther off than what it looks like right now. So let's go ahead and move on to the next one. Determine the relationship shown as proportional. Okay, so once again, we need to decide, is this proportional? So I'm going to compare this is my independent, this is my dependent. I'm going to compare my y to my x. And okay, now that's just 2/3. That's 2/3. That's 2/3. And that's 2/3. Okay, it looks like I'm off to a good start. It looks like all my rates of change are exactly the same. Let's look at the graph and see if it trends towards 0, 0. So 3, 2, 6, 4, 9, 6, right there, and 12, 8. Oh, I think we might be in luck. Let's take a look here. All right, it looks good to me. It trends towards 0, 0, showing me that it is proportional. It has the same rate of change the whole time, and it goes through 0, 0. So I'm going to say, yes, this is proportional. And this time, my constant proportionality, the part that doesn't change, it's constant, it never changes, is 2/3. So I'm going to say my k value for my equation will be 2/3, and my actual equation, y will equal 2/3 x. All right, so very similar to what we've done in the past, except for now we're adding a graph, and we have to make sure that it does actually trend towards and go through 0, 0. So I'm going to try one more, and I'm going to compare the y values to the x values again. 1 compared to 3, 2 compared to 4, 3 compared to 5, and 4 compared to 6. 1/3, 1/2. Uh-oh. That's not good, because it tells me it's changing. We don't have a constant of proportionality because it changes, and that wouldn't be called constant. So what we're going to do is we're going to say, no, it can't be proportional, but let's take a look at the graph anyway. It might still be linear. Let's move over 3 up 1, over 4 up 2, over 5 up 3, and over 6 up 4. And if you look, it is a line, and it does increase the same amount each time, but it's not a direct variation and is not proportional because it doesn't go through the origin. And you can tell that by comparing these ratios of points. They should all be exactly the same. So there will not be a constant of proportionality, and we can't come up with an equation for this line at this point in our young lives. But someday we will. So I guess what you need to know about the graphs is a proportional graph is known as a direct variation. It goes through the origin. Origin is referred to as the point 0, 0. So hopefully now you know how to graph a direct variation or proportional relationship, and you know that it should go through 0, 0. So that's it for today.